Hello class. So today we're going to go over the quadratic type equations. So for these problems, basically, we'll be looking at equations like this and like this. We're only going to do two examples of these because it stems pretty closely off what we've been talking about. You notice they already look very similar to the quadratic equations that we have been working with. And you may note that the word here substitution. We will be making a substitution. So what we're going to do is we're going to come over. We're going to work this one first, and we're going to say let big X equal x squared. All right. So that's the substitution we are using. And so now we've got this. Every time we see the x squared, we're going to be replacing it into here, into there. So what you notice about this first term here, x to the fourth, that is really, or that could be written as x squared squared. Right? So we can make the substitution on that basis. So we can rewrite this first equation as 2 times big X squared minus big X minus 1 equals 0. And now we simply solve this problem like we normally would. You actually have some options here. You can use factoring, you could use completing the square, or you could use the quadratic equation. Let's use the quadratic equation. Alright, so we say that big X equals, remember the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so we're just going to plug everything like we normally would. So we get our negative. B goes in there, plus or minus the square root of something squared minus 4 times something over 2 something. And so we plug everything in. So our b, looks like that's a negative 1. Negative 1. Okay, and then we look at our a, that's going to be a 2 and a 2. And then we look at our c, and that is also a negative 1. Okay, we got negative 1 twice. Alright, so now let's go ahead and evaluate this guy. And when we do, we get 1 plus or minus the square root of 1 plus 8 over 4, which of course becomes 1 plus or minus the square root of 9, which is 3, all over 4. Alright, so let's go ahead and evaluate this further. Bracket notation. 1 minus 3, that's negative 2. 1 plus 3, that's positive 4, so we got 4 over 4. And so we're left with negative 1/2 and 1. And you might be tempted to say, alright, we did it. We got the quadratic equation and we're done. And if you did that, you would not have gone the whole way down the sidewalk. We've got to go ahead and finish this one because this does not equal little x. This is what big X equals. And what is big X? Well, that's x squared. So we need to go ahead and take the square root of both of these terms to get everything that we need. And so this is going to become x equals the square root of negative 1/2, and then, don't forget positive or negative, and then the square root of 1, which is just 1. And we can go ahead and work this further. Positive or negative, square root of 1 over 2 times I, and then positive or negative 1. And note that this actually summarizes 4 different numbers as a possible solution for this. So there's an interesting note. 4 possible solutions, 4, and the lead term is to the 4th power. There is a correlation there. Alright, so we used this substitution and it made our lives quite a bit easier on this. So let's go ahead and look at the next example here. We're going to do a similar thing. Again, note that we got a lead term here with that power, and then the second term there has that power. And again, we note that the lead term is twice the second one, so we can do once again say let. This time we're going to let big X equal x to the third. And so you can see, this guy right here, well, this is going to be x to the third squared. Alright, so we can go ahead and make our proper substitution now. So we have 2 times big X squared plus big X minus 1 equals 0. Cool. Alright, so let's go ahead and use the quadratic formula again. Again, big X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Alright. Now we're going to fill everything in. Alright, so once you get this set up like this, just plug in all your numbers. Alright, so we've got b, which is 1. So we have b goes here, and a b goes there. And then we've got our a, which is 2, here and here. And then our c, which is negative 1. We put that one here. Alright, so let's go ahead and work this through. So we got a negative 1 plus or minus the square root of 1 plus 8 divided by 4, which of course becomes negative 1 plus or minus the square root of 9, which is 3, all divided by 4. And now we go ahead and work this through, get it in bracket notation. And so first we minus the 3, so we get negative 4 divided by 4. Then we add the 3, so we get negative 2 divided by 4. And we get negative 1 and negative 1/2. Similar results to last time, but not quite the same. And note again, we are not done yet, because big X really means x to the third power, right? So let's go ahead and figure this out. So x, little x, equals the cube root of 1, a negative 1, which is negative 1, right? Because negative 1 times negative 1 times negative 1 is simply negative 1. Alright, and since we took the cube root, that means that that answer is repeated 3 times. So we've got negative 1, negative 1, negative 1. Just like when you take the square root, you have positive or negative, you get 2 results. When you take the cube root, you get 3 results, but the number is repeated 3 times. Okay. Alright, so on the next one, the cube root of negative 1/2, well, just negative 1 times 2 to the 1/3 power, comma, negative 1 over 2 to the 1/3 power, comma, negative 1 over 2 to the 1/3 power. So note we've got 6 solutions, and the lead term had a 6 in the exponent. Not a coincidence. Alright. Cool. So now we've seen 2 examples that we can work with. Let's go ahead and generalize this technique a little bit more. In general, if the second term is half of the lead term, right, that's the term that's in the front, then you can use this technique, the technique what we just used. And in general, with the equation that we have here, we've got our lead term here. A lead term refers to this whole thing. Note the power is n, and then for the next term here, the power is half of that, n over 2. So whenever you're working these, if you notice that, go ahead and get the other two up here. If you notice, this term here is in fact half of this term. You look over on this side here, and you notice that this term is half of that term. And so that's how this works. And also, it's not stated here, but this only works when you have terms like this. You have to be able to simmer the equation down to something that resembles a quadratic with the proper substitution. Okay, and so that's basically it for this part of the handout. Make sure you get some practice with these on the homework. And we're going to go ahead and move on. We're going to move on to inequalities and absolute value inequalities. So first off, what does it mean to have x to be less than 4? Well, say this is 4 right here. We put a hollow point there, and x refers to all the numbers that are less than 4. So we would go this way. And so know what we're saying. We're including all the numbers from negative infinity all the way up to positive 4, but we do not include 4. 4 itself is not included. We include 3.9, we include 3.999, we include 3.999999999, however many nines you want, but you just do not include that 4. And so in an interval notation, the way we would express this is we would say that x equals parentheses negative infinity up to 4. And keep in mind, these parentheses means that you do not include the number. That's what that means. Alright? And note that we've got another parentheses here on infinity. That's just because infinity is kind of a hypothetical number. You can't include it. You can never reach infinity, so therefore you can't include it. Alright, so let's look at this next one here. We got x is in between 10 and 13. So we have 10 here, and we got 13 here. Well, then again, you put your hollow points because you are not including. And again, x is greater than 10 but less than 13. It's in between them. And so we would have all those values there. And so in interval notation, x equals 10 to 13. And that's it. That's how you would express that. Again, note we're not including the 10. We're not including the 13. All right, next one. X is less than 5, and x is equal to or greater than 6. So let's go ahead and write these out. So we got 5 here, and we'll put 6 there. You notice, same thing, same symbol. And 6 is a little bit of a different symbol. We've got this equal sign underneath. So we're saying x is equal to or greater than 6. And so now we're going to not put a hollow point, we're going to put a filled in point. And again, it says we're greater. And over here, x is less than 5, so we go the other direction. And so we got a couple of different things going on here, but that's okay. And so we say x equals negative infinity all the way up to 5. Don't include the point. And now we're going to have this symbol here. This means union. And basically, it's another way of saying and. Okay. All right, and then we would include the 6. All right, notice we got a bracket here now instead of a parentheses. There we are. And so we go from 6 up to infinity. And that's it. That's how we would use our bracket notation, our interval notation there. Okay. So now let's shift this to equations or inequalities that have equations involved. So basically, we want to find all the values of x that satisfy this condition. And we're basically solving for x. Okay, and so let's come over here. We're going to go and solve. So we have 2x plus 3 is equal to or less than 6, and we just treat this like we normally would. We subtract 3 from both sides so that we have 2x is equal to or less than 3, and then we divide both sides by 2. 3/2. Note that we did everything the way that we normally would, and so 3/2, that would be, we'll put a solid circle, x is less than, and so it goes right there. And so this is going to be, so it's 3/2, so it's going to be in between 1 and 2, right? Perfectly halfway. All right, we got it. All right, so before going on to the next one, what if we had a different type? What if we had, I'll do this in a different color so it stands out better. How would we handle, say, negative 2x is less than 10? How would you calculate that? Well, first you got to divide by negative 2. And so you have x is, well, we're going to leave this blank for right now, but will be something negative 5, right? Because 10 divided by negative 2 is negative 5. Note the negative sign here. Anytime you're multiplying or dividing by a negative, you're going to flip that inequality. So it will end up being x is greater than negative 5. And so that will be all the values that would make this guy true. So just something I want to make sure that you keep in mind as you're working through these problems. Alright, so right here we got x minus 3 times x plus 5 is greater than 0. So first off, let's look at what we can immediately tell just by glancing at this. What happens if I plug in 3 for x? If x equals 3, then this is 0. And this will be some number. Well, it'll be 8. But 0 times 8 is 0. And note this symbol here. The whole thing's got to be greater than 0. If it equals 0, we don't include it. So we can say, alright, so we've got 3 here. Actually, let's put 3 over here. And we got a hollow point there. So far we know nothing else. All we know is we do not include 3. And now let's take a look at x equaling negative 5. If we plug in x equals negative 5, well, this would be 0. This would be negative 8. Negative 8 times 0 is 0, which would not satisfy the condition. So we'll just state that's negative 5 and put a hollow point there. I know that's don't have enough tick marks there. We'll just use a different scaling for this one. Okay, so this is good. We already know quite a bit of information. Now, this expression, basically what we're saying, this expression has to be positive. And the only time it'll change from being positive or negative is when it passes through 0. So we can test any of the points in here, for instance, and we'll know if it is in fact going to be in that zone. If it's not in for one, it's not in for any of them. So let's test x equals negative 6. So when you plug negative 6 in, the first one you get negative 9, and negative 6 plus 5, that's negative 1. Well, that's going to equal positive 9. And positive 9 is, in fact, greater than 0. So we include it. So that's good. There we go. Alright, so let's go on to a point somewhere in here. We can pick any point. Let's pick an easy point. We're going to pick x equals 0. When you plug that in, you get negative 3 times positive 5. Well, that's going to be negative 15, and that is less than 0. That is not what we want. Alright, so we do not include this area. Alright. So next interval to test is going to be over in here. And we're free to pick whatever we want. Let's pick x equals 4. And so you plug that in and you get 1 times 9, which is clearly going to be greater than 0, which is what we want, so we include it. Awesome. And that's it. We've got our solution set there. Let's write this in interval notation. And so we'd say x equals negative infinity to negative 5, parentheses union, 3 to infinity. And that's it. Okay. Next one. Alright, here we've got what's called a two-sided inequality. Basically, we're just going to solve this all simultaneously. We're going to note what we got to do is we got to isolate that x in the middle. So we're going to subtract 5 from all 3 points. So we've got negative 5 equal to or less than x, which is less than 6 minus 5, which is 1. And that's it. We're done. This one was a pretty straightforward one. Alright, so we're in between negative 5 and 1. Okay, and then note on the left hand side, closed circle, right hand side here we put a hollow point, and that is it. In interval notation we have negative 5 to 1. Alright, awesome, that's it. All the real numbers inside that interval. Okay, here we are at an inequality involving an absolute value. So once again, let's take a look at this. What does this mean? First off, what does an absolute value mean? Well, an absolute value takes a negative number and makes it positive. And if it's already positive, it leaves it alone. And so, if you wanted to define what the absolute value function is, the absolute value of x equals negative x if x is less than 0, and positive x if x is equal to or greater than 0. Right? Because if x is less than 0, you do a negative times a negative to get a positive. And so when we have this situation here, this simply means that 2x plus 5, positive or negative, is less than 6. And that's one way to think of it. Another way to look at it is that 2x plus 5 must be in between 6, because that's exactly what this works out to. Right? Because you multiply, the one that's negative, because it's 2 different equations, and you'll end up with negative 6 is less than 2x plus 5, and 2x plus 5 is greater than 6. Alright. So now we subtract 5 from all 3 sides that we have here. And so we get negative 11 less than 2x less than 1. Divide through by 2, and you get negative 5.5 is less than x, which is less than 0.5. I just have decided to switch to decimal point simply for convenience. Alright, so we got negative 5.5. We'll put that right here. And then positive 0.5, we'll just put that right there. And note we're using open circles and we're in between those 2 points. And there we are. We got it. So in interval notation we would write x equals negative 5.5 up to 0.5. And that'd be it. Alright, that's basically how you'd work these absolute values. How about we look at one this will be a little bit of a trick question I want you to think about. What if I said 2x plus 3 absolute value is less than -1. What values of x would satisfy this? The answer is nothing satisfies what I just wrote in green. The solution set for this would simply be empty. It'd be an empty set. Or you could simply write x does not exist. Okay. Alright, well that's all I have for this handout. Make sure you do the homework. Email me if you have any questions. And I will talk to you guys next time.